Hi, hello. Hello.
Hello,
Yes, how are you?
I'm great. Thank you.
Okay. So, is it there is another person joining us?
Uh, no, I think it's just me. Oh wait, yes, my dad is joining right now.
Okay. So, can I know your name?
Yeah. I'm Grace. It's nice to meet you.
Okay, great. So, my name is Mr. Ahmed. I am an engineer, computer engineer, 20 years experience. So, I will try my best today to take you to the step of computer science and introduce you to the simple concepts that we will go through in the IGCSE syllabus. Okay, so
Okay, thank you.
okay, good. So first of all, I will start with I will talk about the brain and how you can utilize your brain in the studying, because actually there is a lot of functions that the brain do, and we are not aware of. If we are aware of, we are able to improve how we think and how we perform in the classes and even in exams. So one of the most important things here to know is that our brain um, tend to take information into chunks. So our brain actually perform very well when we try to divide information um, into small chunks like that, and instead of just one whole number in this way. This is just a simple illustration of what the memory chunking is. This memory chunking can, as it works with numbers, it also work with difficult words to pronounce, for example, like this. So when you pronounce each part differently or try to practice it in a separate manner, then when you are able to pronounce each, then you are able to finally say the word correctly as a whole. Um, am I speaking slow or fast? Should I move slightly faster or
It's
slower?
okay. It's okay.
It's okay. Good. So in short, memory chunking is important. It helps you to retain information on the long run. So when you chunk information in this way, um, it have a good effect, like I'm telling you. So if we are studying, so I give you an example, a simple example of a phone number, but you're not studying phone numbers. You are studying complicated information like science, physics, and even computer science here. So how can you actually chunk this information? So to chunk that information, actually, you need to first of all engage with the information that you are learning. Um, you try to increase the amount of senses that you are using to get that information. So you can use visual aids. You can listen to what you are. Um, you can, for example, if you are reading a book, a PDF book, then you might need to use some kind of software that can read the text. So you'll be able to see the text and at the same time listen to it. That will help you engage with the information more. You try to find a relationship and between the information that you are studying. You try to find patterns and connections between different pieces of information you are studying that help you to chunk the information. Chunking information means grouping information together and storing it in relation to each other. And um, so that somehow help you in the retrieval process also. So if you want to recall the information that you study later, either 2 3 months or even in the exam, so that whole information that you chunk together and that you make when you're studying, you make them related to each other, then that actually will help you, like I said, in the retrieval process. When you are recalling the information in the exam, the whole chunk of information that you group together will come back to your mind when you do the recalling process. Am I clear here?
Yeah.
Okay, so like I'm trying to tell you here, okay, one of the most important thing also to build memory chunks is to practice retrieval. Okay, so practice retrieval, um, some of the students do this practice. Okay, they read some information, and then after a while, they tend to say, okay, I want to revise on that information. So they revise by rereading the information again. But actually, this does not really help their brain a lot here. Rereading does not really benefit the brain. So you need to do two things actually to help your brain solidify the understanding and to make the information that you already chunked in the memory to move it to the long-term memory. So to do that, you need to, like I said, practice retrieval. It means that you need to, for example, you studied a piece of text. So after you study it, then you try to close the book and try to write down what you actually grabbed so far from that information. So when you do that, this is a recalling process. The recalling process actually help you a lot and help you to solidify that information in your long-term memory. And not only that, so you study the piece of text and then you try to retrieve it by recalling, by closing the book. That's one thing. But you also need to do that kind of recalling process from time to time. So you cannot say that, oh, I studied this piece of text or even that computer science lesson, and then I left it for 2 or 3 months without revising. So definitely you will forget. You will start to forget. So when you do a spaced repetition, so after every maybe for example every week you do some revision on the information that you studied, then you can guarantee that this information will last longer in your long-term memory, and the brain will start to give priority to that information because the brain will notice what you are always retrieving, and then he will start to strengthen the connection of that information in your brain, and that is your recalling. So when you try to recall the information in the exam, it will be easy for you. It will not be difficult. Did I make sense in what I'm explaining to you?
Yeah, it makes sense.
Okay, good. Um, so before I explain to you something that is related to your to parts of your brain that you need to utilize also, um, do you know what is the purpose of a book index?
And to tell you which page has what kind of information. Yeah,
Okay,
and which topics are allocated to which pages.
okay, that's great. So actually, we have uh, um, one piece of uh, part of the brain that actually act as a book index, but it is a memory index for us. So we have something called the hippocampus. This hippocampus, we have two portion of it in our brain. So when you are studying something in a lesson, like when you are listening to me at the moment, so the information is actually flowed first to the one part of the brain. Mostly they call it a working memory. So this working memory is a short-term memory. It doesn't last for long, and it only can capture a limited amount of information for a few minutes. So to grab that information, your brain have used the hippocampus. This hippocampus is two portions inside your brain that try to organize and index the information and pass it to the long-term memory. The long-term memory is actually a thin layer all over your brain here, like that. Okay, so this orchestration of the information or organizing the information from your working memory here to your permanent memory go through the hippocampus, like we said. This is the hippocampus. So there is something that we should actually notice, and most of the teacher who really studied neuroscience, and most of the teacher who teach in schools actually do. So the hippocampus actually got flowed with information in adults between 10 to 15 minutes. So teachers tend to use 1 or 2 minutes to clean the board, or even to open their book and check the syllabus every 10 to 15 minutes. When they do that, they give the students time for the hippocampus to actually orchestrate and index the information out. So, because if they don't do that, you are like you're having a cup and you keep pouring information here. It's like it's not information in a cup, but it's like a water. You're pouring water until the water keep flooding out or coming out of the cup. So if this happens, you are not making use of what you are learning from the teacher. So like I said, every 10 to 15 minutes, teacher typically who are aware of that, they will take 1 or 2 minutes of silence to help the students grab or digest the information. And this is how it actually works. The hippocampus actually has the time to really index the information that he grabbed from the working memory, or the information that you already grabbed from your teacher. Okay, so internally this is how it works: information flow from working memory to hippocampus, from hippocampus to long-term memory. Did I make sense? Can you tell me, what did you understand from me so far?
I just understood that the hippocampus,
Yes.
it's like there's two of them in the brain, and then it basically needs time to, like what I want to say, reload. Like in terms of like teachers, they take a break. You said right? They every 10 to 15 minutes, they let the students process in their brains about like what is actually going on, what they learned from the previous 10 to 15 minutes by like, I don't know, spending time cleaning the board or something. And then making sure that the students actually like get the information in their heads, like actually memorize the information.
Excellent, excellent, excellent. That's excellent. So Grace, please be aware, when I'm asking questions, I'm not testing your abilities, or actually questioning you just to really see if you are focusing or not. But actually, when I'm testing you, it is actually an act of recalling the information from your brain. So when I'm doing that, that actually help your brain to first organize the information, and it's an act of solidifying that information in your long-term memory. Of course, I take the first step in doing so when I'm teaching you the class. The second steps or third steps act on your behalf later when you study what I teach you. But so again, I'm not a person who's going to examine you. I am not here to test your abilities. I'm here to assist you and push you forward. And so my question is serve only that purpose. So don't think ever that I'm testing your abilities, or I am just trying to check if you are good or bad. No, whatever position you are in, I will push you forward, and I will try to help you and assist you. Okay, so don't worry too much if I ask you many questions. Okay, is this fine?
Yeah.
Okay, good. So let us move to the next thing. So I want to tell you here, information in the brain is linked together, and this kind of, so the start of when you grab information and it is start to be stored in the brain, the connections is like that. Okay, of course you are not studying neuroscience, but what I want to say here, this is first when you learn the information, and this is after you start to sleep. So what I want to tell you, as a student, you don't really care about this kind of connection, how it look like, it's not in your syllabus. But I want to tell you that sleeping is very, very important for your brain to consolidate the information and to start to build links for the information. So when you sleep, the brain tend to replay all the information and memories that you have and you experience, and try to find patterns between different information and try to link them together. So never ever in the night of the exam that you stay all the night without sleeping and then you go second day for the exam. That's actually very bad. Okay, so a good sleep is very important. You study whatever you want to study. When the time finish, sleeping is actually very important. Okay.
Okay.
And another thing to note here, please, that this kind of consolidation that happen in the memory does not happen one shot. It takes time. So it is not one night sleep that will cause that kind of consolidation or memory linking inside your brain. No, it takes many nights. Some studies say that it takes weeks, and sometimes it takes months. So it is not one night sleep that will get you perfect. It's a continuous good sleep that will help your brain a lot. Does this make sense to you?
Yeah.
Did I manage to convey what is important in this kind of slide?
Yeah.
Okay, so how can you benefit from that?
Oh, you can, like, first you have a good night's rest, so your brain will process like all the like, how do you say, all the things you learned like that day, and you won't like wait, hold on. You also said it's like not a one night thing. So if I continuously get a good night's sleep for like maybe weeks or like months, then my brain's memory will improve, and yeah. And
Okay,
yeah.
that's excellent. So I also want to tell you one thing, that uh, now you're studying computer science. Um, do you think that studying computer science or even studying physics or math affect your brain and improve your abilities to learn computer science? Do you think different subjects are actually related to each other?
Um, I think they all have something in common, which is like you don't really have to memorize. Like it's not like biology or like other like history or other subjects that you actually need to memorize word by word. It's not like that. It's like a concept. So I think that's one thing that links all three of these subjects.
Okay, but in fact, in reality, even if you're talking about biology, and even if you study geography or even history, all, I mean, indirect relation these subjects have together, yes, but actually the effect, the more information you pass to your brain, um, the the better the consolidation, the information and consolidation happen in your brain, even though you think that information is not related. So the studies tend to say that people who read a lot, who learn a lot, even if they learn different subjects that is not directly related at all. So if we say about physics and math and computer science, maybe it's slightly related because there's not a lot of memorization here. But I'm talking about different subjects like history, geography, or even biology. They are not directly related to computer science and math, but the more information, good information that you give to your brain actually responds in a better consolidation of information and better ability to solve problems. So that is what you really need. So instead of so just to put it in short, instead of watching videos, TikTok videos, and putting information that is not really helpful to your brain, if you read a book on the opposite side, even if it is not related, it will definitely help your brain a lot and improve your problem solving abilities. So problem solving abilities, you need it in math, you need it in any exam that you pass through, you need it in your life situations to help you. Okay. So does this make sense to you? Did I make sense?
Yeah.
Okay. So okay, that's already. So the last thing we're going to talk about memory here is that your brain actually work in two kind of thinking. So you have focus thinking and you have diffuse mode thinking. Focus mode, now you are focusing with me, so your brain at the moment is in the focus mode. So focus mode have its own benefits, but diffuse mode is actually very interesting to us. So you need to learn how you are able to put your brain in diffuse mode. Diffuse mode is activated when you are relaxed, you're walking, you're drinking coffee, and you are thinking about nothing. So when you have a problem and you're not able to solve, either in computer science, math, or any other subject that you face, so I would say go and take a shower, go walk beside the sea, or go walking in the garden or something. So make your brain relax. When you go into this relaxation mode, you are entering the diffuse mode. So that will help you a lot. So when if you face a problem, don't just keep trying to solve it. No, just stop, take a break, 10 to 15 minutes, make your brain clear. Don't think about anything. Forget about all your problems that you have. Just relax. That will give you a push forward, actually. Okay, and that actually can explain why many people, when they are in the relaxation, they find solution for problems. So some people, the ideas keep rushing to the brain when they are taking shower. So that is because they are so much relaxed and the diffuse mode thinking is already activated. Did I make sense to you? Did you know
Yeah,
now how can you activate the diffuse mode thinking?
yeah.
If you have a problem, what are you going to do?
Just take a break, like 10 to 15 minutes, or like take a shower, walk in the garden, or like, yeah,
Perfect,
just
perfect,
let your
perfect.
brain relax.
Okay, that's good. So I will go fast about how you are able to find resources. So for every student I teach, typically I create a unique link that he's able to use all the time to reach his class resources. So, so of course that's not yours, but this is just a sample example of how you are able to reach your class resources. So inside, this is a post that is created once your class started. So after that, you're able to find the class date and all the video recording for that class. If it is 1 hour and a half, you'll find that you have 3 video recordings, 30 minutes each. And here also, you'll be able to find information about any class code that we write. If I write any Python code during the class, that will be stored here. If I share with you any slides during the class, that will be in the files section here. If I pass you any exercise, it will be under the exercise portion here. Did I make sense? Did you understand or grab what I'm telling you?
Yeah,
Is it clear?
yeah,
Okay, good. So typically all the files is stored in a Google Drive in this way. Okay, and
okay.
this is an example of how it works. Typically, after we solve the so if you have an exercise, the next class, we are going to discuss about that exercise. If you face a problem and if you come up with a solution, I will check if this is the ideal solution or not, and I will tell you the remarks. And then I will also provide you with copy of the answer, of the ideal answer. Okay. If I write on the whiteboard during my class, I will store that in a PDF file. It will also be shared in the link provided to you. So here in the link, if we go to the previous slide here, under the class, under the files here, it's possible that you find many files, possibly the slides. After it will come the whiteboard, if I explained on the whiteboard. Okay, is it clear?
Okay. Yeah.
So typically, of course, you're able to trace and record 1 or 2 videos or even 10 videos. But if we're talking about long-term solution, if you're talking about 30 to 40, 50 videos, to be able to actually go and find the correct videos that you're searching for. So for that, I actually upload all the videos into a YouTube channel, and I put them under a playlist specific for you. I put titles. I no longer put descriptions because it takes so much time and it's a bit costly on terms of money. So I only put I put the class name. If it is related to you here, I sometimes I put a short of your name. So instead of writing Grace, I might write G, and maybe I write sometimes I write um, 2 letters of the country. So if it's Malaysia, I write MY, just to recognize files, because I'm teaching many students, and of course all of them have recordings. So typically I try my best to put a description that really describe what we really explained in short during that video. Okay, so you will be able to find information using the video and the slides, and you can relate. If you cannot find, then you can come back to me and I will try to guide you as much as I can. Okay, is that clear? Do you have any questions?
Yeah. No.
Okay, so during our coding, so we will depend a lot on coding during the class, because again, if you don't code and practice coding, and I see you with my eyes coding properly, then you will face problem. Even smart people I have seen, I've taught a lot of smart people, and they tend to forget, actually. They tend to forget a portion of the code when they are writing. They know the important parts and they write it down, but of course in the exam they will take a whole picture, not only the important portion. If you forget syntax here and there, definitely you will lose marks. So we will use that Repellent. This is an online interpreter that we always use with Python. So you need an account. It's free. You need to register an account. If you're having Gmail or even an account on Google, you can easily able to register an account in or Rebel it. So in the next class, it will be good that you always have your account ready, and so that you are able to share your screen with me and share with me if I give you an exercise during the class. Okay?
Okay.
Good. So now we are talking about, we are just trying to go through the computer science subject itself. So may I know, what is your background? I mean, what do you know about computers in general? And what do you know about programming language?
Programming language like
Yeah.
Python, C++, these
Have you
things.
tried any of this?
Well, I've tried Python, but I'm not very good at it. I've actually tried Replit, but like that's just in class. And I heard of other like languages, but I haven't tried it, like C, right? And then what else? Wait, yeah.
Java?
And then JavaScript or something. Yeah.
Okay. So
That
you,
I've heard of, but I haven't tried.
okay. And do you know anything about low-level languages?
Uh,
Do you know, do you know what
I
the
think
difference?
I saw it before. I heard of it before. I think I forgot.
Okay, never mind. So a low-level language is actually a language that is very close to the processor. Do you know what the meaning of processor?
Like I don't know, something that processes data. I don't know.
Yes, it's true. Yes, you're correct here. So this is an example of a processor. This is an AMD processor. This is an Intel processor. This is really how they look like. So everything that is processed, every single line of programming language that we write is actually processed here inside the processor. If it is not processed, it means that it's not going to be executed. So we need the processor a lot, and we depend on the capability and how fast is the processor to be able to execute the instructions that we give to them. So a low-level language it was created 50 or 60 years ago. So when I started programming in the schools, we learned low-level languages, and it was very difficult. An example of a low-level language, just two examples or two types of languages, something called machine code and assembly. Can you see this kind of mnemonics and this kind of numbers? So this is an example of a machine code. It is a group of numbers, and that is because inside the processor itself, the processor only understands something called binary. Binary is. Did you hear what is binary before?
Yeah, it's 0 and 1s.
Yes. So yeah. So machine code is a group of binary numbers, and sometimes we write them in a hexa format because it's slightly readable. Did you hear about hexa format before?
Yeah, hexadecimal.
Yes, exactly. So assembly language come after the machine code. So every processor have its own machine code. If we're talking about AMD processor, they have their own instruction set, commands that we are able to use to execute programs or to write programs. And so every processor have its own machine code, okay? But machine code, if it is binary in this format, it is not easy to remember. If you have 10, 20 lines full of numbers that is full of ones and zeros only, it is very hard for the brain to digest or even to remember. So they tend to simplify that by creating assembly language. Assembly language is more readable, slightly readable. I will share with you something that. So now, first, before I explain anything about assembly, I want to make sure. Have you seen a motherboard before?
Yeah.
Okay, good. So this is a processor, and this is how it is installed in the motherboard. This is how a RAM looks like. So I would say this is a RAM, and inside the RAM, information is stored. This is data, and the RAM is actually full of addresses. So for every location that we are able to store data inside, there is an address for that location. Exactly same like every house that we have in our living areas have a number. So if we want to send information from one place to another, so we say, okay, house number 100 or house number 200 in this street, in this taman or local community. So in this city, there is a street, and inside the street, there is houses, and inside the houses or outside the houses, we mark the houses with numbers. Am I right? Grace,
Yeah.
are
Oh,
you
yeah,
speaking
yeah.
for me?
Oh, I thought you said something else.
Okay, so you are aware now that inside the memory or inside the RAM, we have addresses and a place for an address, and we have data, right?
Yeah.
Okay, so the data is stored in binary. And if we have, let me see, okay, so just an example, and in Python, if I want to add two numbers, I would just write one number, one line like that, sum equal 5 plus 2. I'm adding here what? I'm adding two integers or two numbers. 5 is a decimal number, and 2 also is a decimal number, right?
Yeah.
Okay. So in total, it should be 7, right?
Yeah.
Perfect. And if we look at the alternative or the similar code to achieve that operation that we're talking about, summing two numbers here in assembly language, we actually need 3 lines. So the first line, LDA, the LDA 8. So can you guess what this number or what this line do? LD 8.
I don't know. Is it
No, no.
hexadecimal?
Yeah. Okay.
Wait, no.
So the thing is, while we are writing in assembly, we need to be addressing. This is
Oh, is it on the motherboard? Is it the one on the motherboard? Like
so
the
yes.
labels?
So actually, 8 is an address in the memory, in the RAM, that actually have information stored inside. And if you look at 9 here, this is another address in the RAM that we have information stored inside. 10 is another place in the memory that is storing something. So LDA will tell the computer, please go to the address that is called 8, retrieve 5, and store that 5 inside a place in the CPU that is called accumulator. Did you hear about accumulator before?
Like secondary storage?
And no, accumulator is not a secondary storage. Let me share with you here. So inside the CPU, we have a register that is called accumulator. So when I want to do any operations, arithmetic operation or any other operations, I need to take the information from the RAM. I need to load it inside the CPU, inside the register called accumulator. We will talk about that in more details, but for now, just bear with me. So, okay, we have almost 2 minutes. Oops, yeah, never mind. So what I want to say in short here, that we load the information that's stored at 5. We assume that here, sorry, at 8, at the address 8, and we have 5 decimal, 5 integer data stored inside the address 8 in the memory here. And so that is what this line do. Add 9, it will tell the computer, go to the address 9, bring whatever information inside and add it to whatever was stored in the accumulator inside the CPU. We have here 5, so he will add whatever he retrieved from 9, which is 2 in this case, and then add it to 5. And we'll store the result inside the accumulator. STA is telling, go to bring whatever information in the accumulator, which is 7 in this case, and store it in the address 10 in the memory. So you have to deal with memory addresses when you are writing assembly code. And I would like to also tell you that assembly language, when it is translated to machine code, it's translated to 1 and 0s in this format. So this is something actually difficult to deal with. That's why they come up with high level languages like Python. So did you understand anything from what I said?
Yeah.
Yeah. Are you able to tell me anything from what you grabbed so far?
Like from this slide or in general?
No, I mean in this slide specifically.
In this slide. So basically there is oh crap, what is that called? Accumulators. It starts with A anyway.
Accumulator, yes. ACC, yes.
Oh yes, that, yes. So there's an accumulator which stores the data, which is stored in binary, and then it's also in the CPU, and